Alright, so what we have here is just a plain old spreadsheet whereby we've been asked to do these various tasks. So let's get started. So first one is simply asking if we could basically add these values. So what I'll do over here is I'll label what I'm going to do in the next cell for me, the human. I'm going to sum or add these. Again, this is just for my own benefit. Here I'll tell the spreadsheet to add these up by having it do a function. That function will be introduced by equal sum parentheses. So again, the equal sign is to tell the computer or the spreadsheet this is a function that's coming up. What function is that? It's a function called sum. And then we're going to click and drag the values we want added. So be careful not to click and drag into the actual cell containing the function, otherwise you're going to have a circular logic problem. Here we go, we hit enter, and we see we have now summed up these numbers. So what I like to do is I like to somehow offset these so I know what I'm doing later at a glance. One way to do that is just to highlight or change the color. Now I know that the 985 is a sum of those values. All right, so we like to average these values here. So again, it's good practice to introduce a name for what you're doing so that when you come back to this in a month or so, you're not having to think, what was I thinking? What am I doing? You could, rebuild your thinking by looking at each one of the functions and recreating that, but that really is a waste of effort because you're not going to remember this. So let's label. That's the mark of somebody who knows what they're doing and knows that the whole point of using a computer is to decrease work overall. And one way to do that is to label properly. All right, so let's average these up. So we'll tell the spreadsheet, hey, we need a function. So we'll say equal sign, that tells the computer, please be on the lookout for a function. What's that function? Average, parentheses. I'm then going to click and drag on the numbers. I'm going to release the mouse now and hit enter. There's my average. Again, I'm going to maybe pick a different color, maybe, I don't know, orange. Let me do that one too. Make it bold too, kind of hard to see. There we go. One other thing, when looking at this, it just doesn't look like the rest of the numbers. Just too many decimal places. So go up and look at format, and we want to format the number or format the cell, depending upon which spreadsheet you're using. So we're going to format it to the same number of decimal places, 3. And then it looks more like the numbers you're using. Again, always be thinking, having, an eye for some design. I mean, my goodness, if it's not good looking, probably it's not good. That's just reality. So let's always keep an eye out for the aesthetic. All right, we want to sort this. Now for this is slightly different. This is not using a function, but rather telling the spreadsheet to do something, to act upon the numbers. So let's take a look at how we do that. All right, so what we're going to do is we're going to tell the spreadsheet to sort these values. So first things first, let's select it. Let's go under, in this case I'm using Excel, but I'll hit sort. It's going to be the same on any other spreadsheet. And we're going to sort that column that we just selected based upon its values, smallest to largest. You would select my list has headers is if you had, let's say, a header up here and you didn't want the computer to touch it. You just want to work on the numbers. In this case, I only selected the numbers. So I don't need to select that. I'm going to hit OK. And we see that it has now sorted these numbers from smallest to largest. All right, we've now performed a couple of functions that have been built into the spreadsheet, but there will come a time where you want to do a function, a custom function that just doesn't exist, and you have to create it yourself. So what is that? Well, here's a function that's not programmed in density. Density, again, is mass. divided by volume. So we've got to figure that out. So what we're going to do is we're going to say, okay, that's our density. I'm sorry, that's our volume. So let's give ourselves plenty of room. And I'd like to find out density. Oops. Let's type in density. All right. So we've been told to assume 15 mils volume. So I'm going to delete that. We're good. Here's our density. Here's our mass value, and we're going to calculate density. We could go equal mass, cell next door to it, divide by 15 milliliters. And if we do that, we get this as our density. It's useful to put, of course, the units. The units aren't labeled here, unfortunately, so we're going to have to assume that's what they meant. But it doesn't matter. We're just trying to introduce a custom function. So again, how did I do it? Again, let's go equal sign. Selected the cell next to it for mass, hit divide, and I put in my 15, hit enter. Now, there it is. There's my density. If I wanted to then do the density of the next one, I could type it in again, equal sign, select the cell, divide by, etc. But let's not do that. That would take forever. What we're going to do here instead is we're going to see on the lower right-hand side, we're going to see a little box. I'm going to come over where the cursor changes. I'm going to click and drag down, and now I see that my computer has calculated the density for all of these values, one after another. Wonderful, right? You know what? While we're at here, while we put the average density, and again I will put equal sign average. I will click and drag. Here's my average density, and I'll put my standard deviation of my density. See what I got. STD, EV, parentheses. I will select that, and here we go. So, and I will change the color on that so it's a little bit easier to see. Maybe make it bold. So I see that I can introduce a custom function just as easily as before. Now, here's where we're going to, I think, play a little bit with it and see if we can make this function a whole lot better. It's right now at work, but what if we come back and say, hey, we made a mistake. I mean, we figured out the mass each time, and I'm just assuming the volume is 15 milliliters, but I typed in 15 milliliters each time. What if that changes, or what if I made a mistake? How can I fix that in the future? I would have to manually fix one at a time. That's not very good. So let's do this a lot better. Okay, so let's come back. This is all garbage, I think. So I'm just going to clear that out. Let's just clean it out. I'm going to put here volume. This is real life now. I'm going to measure my volume, and that volume I'm going to determine it in lab as, let's say, 15.0. And I go, all right, so first things first, I could format this to the proper number of decimal places. Maybe it's 1 decimal place. All right, that's good. And I see, all right, so I want, again, my density to be mass divided by volume. Okay, so I'm going to put equal sign, mass, click that, divide by, and now my volume, instead of typing 15, I'm simply going to say, hey, my volume's right here. But I want the spreadsheet not to change that. That's always going to remain the same for all of these values. So I have to tell the spreadsheet, hey, don't change that. I'm going to use what's known as absolute referencing. That is to say, instead of I-17, I'm going to put $, I, $17. The dollar signs tell the spreadsheet, hey, don't change the thing right after it. In this case, the column I, and then the row number 17. Now hit enter. Well, what did it do? Well, it took that number, 15.685, and it divided by the value inside that cell at I-17. Now, the dollar signs, we don't know what's going on yet, but it's basically to lock down so it doesn't change that number or that reference at any time. Because when I now click and drag down, I again calculate based upon this 15 milliliter. Now, try this without the dollar sign and see what happens. What will happen is it will simply change the location it looks for by decreasing it by 1, 2, 3, and so on. So try it with and without the dollar signs and see what happens. All right, now let's say I did this and you go, well, it's the exact same number. I didn't really save any time, right? Well, wrong. I saved a lot of time actually, because this is a variable, right? This is a variable. It could change. I come back and I do this experiment again with maybe new masses. I could input my new masses, but my volumes, well, what can I do? Well, that's why I did this. So I can now change the volume. Let's say let's say the easiest case. I made a mistake. I misread my volume. My volume should have been 14.75. Well, once I changed this, let's look at all the densities. They all updated immediately. So I can go back and save myself quite a lot of time without having to recalculate this one at a time. What would you report? Well, this would be ridiculous to report all these values in your conclusion. You always report what you got as a group, average and standard deviation being a pretty good start. So we see again how we use this tool, spreadsheet, to perform a calculation, a repeated calculation, redundant, this is just mind-numbingly dumb, in order for it to distill all that information down into something we can now report and be proud of it. Again, in lab, you should be spending most of your time doing these tasks, not computing. You should be getting mass 1, mass 2, mass 3. You should be doing it repeatedly until you feel comfortable, until you've trained your hands to perform these tasks, these physical tasks well. Calculating this up is just a waste of time. Why not use a machine to do that? And by the way, it's going to always be correct if you know how to use it. You'll always be correct in how to calculate. Whether or not you can calculate or rather get these masses very well and the volumes very well, that's another task. Actually, probably what you should have done if you're going to do this, I would probably take the volume if this were a pipette 3 times and then use the average for my density. That would be even a better approach. But it's a first step, right? All right, let's continue. All right, so we want to graph all these results. What have we got? We got volume, we got mass. Okay, that's great. What do we want? Oh, density. All right. So what we're going to do is we're going to plot the volume over the mass. And you might be thinking to yourself at this moment, can't we just do what we did here? Well, yeah, we're just trying something different. Let's graph these numbers. So first things first, let's select the data and let's go under Insert Chart, and we want to always insert a scatter plot. That will always be useful. Don't be fooled by these. Always go for a scatter plot. And let's just go for the first one. Don't be fooled again and say, well, I want lines. We'll introduce the lines ourselves. So we just want the first one. No lines. Oh, that looks ugly, right? And let's just make it bigger. All right. First off, let's change this. We're going to go, density determination. Fabulous. This, let's get rid of it. This right here. Let's see if we could, format axes. Well, let's see. Text box. Where is it? Oh, they've always changed. Oh, there it is. Oh, my goodness. There it is. There it is. So, okay, let's take a look. We got to add axes label. So this goes from 0 to 45. So this is our volume reading, obviously. So we have volume down here, and we have mass over here. So let's label either one. Horizontal first. I don't know. I guess we'll do that one. I'll add this one. This one was, again, what volume in milliliters. I will now add vertical axes here. Let's just label this one. This is what mass in grams. So we do that so red hot grams, okay. And whoa, what do we got? Nothing. Well, let's select one of the data points. We see that they were all selected, and we're going to right click, and we'd like to add a trend line. What kind of trend line are we going to add? Well, let's just add linear. And we're going to go to options, and we're going to hit display the equation and the r squared. All right. Well, let's take a look. First off, we can't see that, so I'm going to go over to layout, or rather home, I guess. Oops. Where did it go? There we go. I'm going to make this now a little bit bigger. Let's make the whole thing bigger, right? So it's easier to see. Okay. What did I do? I just, oops. I just want to make this equation, ridiculously big. This equation right here represents this trend line. The r squared is a goodness of fit, and we see it's a pretty good fit. 2 9s, which is acceptable. But let's look at the number here. This number, of course, represents a slope. The slope is rise over run. Rise is mass. Run is volume. Mass over volume is density. Therefore, 1.0507 is the density. So sometimes we can use graphs in order to convey information. Sometimes we can use it algebraically. Either way. Okay, so let's start going off and doing some more work. So we want to sort the type and find each density, average, and find error. All right. So this is a true density. That's the temperature. This is mass. Oh, I'm sorry. And then we also have to assume each is 25 milliliters. Okay. So what we're going to do is we're going to first select the data. In this case, I am selecting the type and mass and dragging down. So I do have a header here. So when I go into data sort, I'm going to go sort by values, A to Z, and I do have headers. So I'm going to select that. And did we see how it changed? It said, okay, I won't worry about the first row. We hit OK. Oops, what did I do? So sort by, oh yeah. Sort by type, okay. Smallest to largest. Okay, so we're going to sort by the first column, and we really don't care about the second column. Okay. So here we go. We have now got all the 1s selected. We've got all the 2s selected, and all the 3s selected, and 4. So first things first is let's put in density. And again, we're going to put in a custom function, so equal sign. This number here, divide by 25. Oh, I didn't put it in, so let me hit cancel. And I'll put, volume, and I'll put 25 milliliters. So I'll come back, and I'm just going to put here, equal sign, this mass, divide by this volume. And again, this volume never changes, so I'm going to come back and put dollar signs in front, $S, $7, hit enter. There's my density. I'm now going to click and drag down, see how the cursor changes. Click and drag down. And now I have my density for all my 1s. And while I'm here, why don't I just change the color so it's easier for me to see stuff. Let's say for 3s, I'll do the same thing here. So all these 1 things, whatever they are, let's do the average. Average density for 1, equal sign average. Enter. And I'll do the same here for average density of 2 things, whatever that is. Oops, I just misspelled that. Average, yeah. Boom, boom, boom. And average D3. And for the 3 things, again, these numbers here, average D1, D2, D3. That's just for my own benefit, not for the computer. Call it whatever you want. And I'll do this here again. Average D4, average of these numbers. Again, I don't know what that number is, so let's see how good do these numbers deviate very much from one another. We'll put standard deviation. I'll do the same to see if these numbers are somehow different. Again, we get to see how we can change, or rather look at the data now much more intelligently. Before we were just, looking, with very limited eyesight. Here we've got very good eyesight. We can see what's going on. We see, the various, let's take a look. Everything's to, 4 decimal places. So let's make these numbers to 4 decimal places so everyone looks the same. So let me go under Format, Cells, and I'll just make everyone 4 decimal places so it's easier to see. So this is in the hundreds place, thousands place, hundreds place. So it looks like this number has the smallest deviation, whatever D3 is, whatever this 3 thing is. So that has the least amount of deviation. And it looks like this one over here has the greatest amount. It looks like it has greatest amount. But, there we go. Wait a second, what's this? We also know the true value, true density. So let's figure out the error. What's the difference in error? Oh, well, it would make sense to put it right next to it. How can I do that? Well, I'm just going to shift everyone over to the right. Usually we shift everything to the left as the song goes, but we'll shift it to the right. So I'll select this column, I'll right-click, Insert, and there we go. We just shifted everyone to the right, and I'm going to put over here Error Calculation. And you might be going, I totally forgot the error calculation. That's fine. For the purposes of this, we really don't. You don't need to remember it. I'm just doing it just to use Excel. So I'll do absolute value of this value minus my true value. And again, I don't want the spreadsheet to change. I'll put $signs for absolute referencing. Divide by, again, my true value. And I don't want that to change. So I'll put $signs in front of it. And I will now select this all the way down. I will, get rid of this so it looks nice. And I want to see this as a percentage. So I'll say data, format cells. I'll say, hey, call this a percentage. 1 decimal place is fine. And now I can see which one has the greatest error. Now, let's just put it here. Average D1 error equals sign average, parentheses. I'll just take, the average of the error. Now, mind you, I got to, again, unfortunately tell the computer, hey, that's a percent. So let's format the cell and call it a percent. 1 decimal, okay. So this is my average D2, whatever that is, error. Average of my error calculation. There we go. I'll format the cell one more time, call that percent. 1 decimal is fine, who cares? It's just for our benefit, our own eyeballs. Average D3 error calculation. Oh, I misspelled it. Okay. Enter. Let's see what we got. Let's just reformat that to a percent. Why not? 1 decimal is fine. And average D4 error. Oh, this one, it remembers. Okay, smart. Anyways, let's take a look at the data now. We have really done a lot. You probably have totally spaced out by this point. that's fine. Just, come back and do it again. Just try to understand, the logic or what we're trying to do. So again, what do? We introduced a custom function called density. Well, first off, we sorted so we could get the ones, whatever they are, the twos, whatever they are, all together. Then we have a custom function called density. We created it, equal sign, And then we said, hey, look, let's just average up everything in the one group and see what its standard deviation is. And then do it for the two group, 3 and 4. And then we thought, well, wait a second, if we have the true value, we could perform an error calculation. Again, these numbers seemingly go all over the map, but we see that the percent error on average for this one thing, whatever it is about 2%. For 2 is about 3%. For 3 it's about 0.2%. And for this other one, D4, it's about 2%. So we see this D3, this 3 thing, whatever 3 is, gave us a number that didn't change very much based upon a standard deviation. And it was a pretty good number because it's very close to the true value. It's about 2.2% off from the true value or the accepted value. So we're allowed to now report that and say, hey, look, D3 has these 2 things going for it. Does not deviate very much. It gives you the same number repeatedly. And that number is really quite good. It's very close to the true value as in terms of an error calculation. This would be a wonderful tool now to use later. But let's take a look at how powerful it really is. We made a mistake. We should not have had 25 milliliters. Silly us. It was 12.75 milliliters. So there we go, we're done. See what I mean? By having it perform the calculation properly, we could put whatever numbers we want in here and it'll automatically recalculate on the fly. So, imagine that. It's a pretty cool toy.